Brilliant. We've got 200 people doing that, so obviously we want to beat that this time. We want to get 250, 300 people applying to that questionnaire. So I'm Rick Dunn. I work at the University of Birmingham over in the UK. And really, I'm just going to talk about, and Dan's actually covered some of this, so it's going to make me talk a bit quicker, which is great. I'm going to talk about quality assurance and quality control, because sometimes people get confused about what is quality assurance, what is quality control. So I'm going to talk about that briefly. Dan's given two very good definitions already for that. Talk about some of the important aspects of that. We don't have 15 minutes, it's by no means enough to talk about quality assurance. Think about what's fit for purpose. Okay, so we're trying to design a study, we're trying to design an analytical method which is fit for purpose, so you need to define what the objectives are. I'll talk briefly about QC samples. Everybody that knows me knows how passionate I am about QC samples. And then really just focusing on, as I say, if there's any questions at the end, then I'm happy to take those at the end of the session. Okay, so what's quality assurance, what's quality control? As I said, Dan gave a very good example, very good definitions of that. Really, quality assurance is the planning, okay, before you actually perform the study. So it's anything from SOPs, training, all those types of aspects, quality assurance that you're going to apply through those studies. Whereas quality control is really providing evidence of the quality of the study that you've been performed or you are performing within there. So quality assurance basically is before you do the study, quality control is during and after the study, and it might feed into your next study, as Dan said, also within there. So quality assurance, quality control are different aspects, and really quality control is part of the quality assurance process within there. So some things to think about. So these are some of the aspects that you want to be thinking about within quality assurance. We've heard again about some of these. Validation of the analytical method. So I'll talk a bit about that in a minute, whether you're doing that for a targeted metabolomics study or a non-targeted study within there. We've already heard about the importance of standard operating procedures for every process that you're going to be performing within there. And then following on from that is the training and competence test to make sure that all staff are doing everything the same way, okay, all of the time, and making sure that there's various records being able to show that. I do like that one, when all else fails, read instructions, so it should be the other way around. You should be reading instructions at the start every time. Okay, so other aspects you need to be thinking about, things such as instrument calibration and maintenance within there, so the frequency, the SOP for that obviously, the annual preventative maintenance, you'll see an example in a minute where annual preventative maintenance caused a big difference in sensitivity within there. How do you deal with that? QC samples, again, I'll talk about those in a minute. But again, record keeping, you need records to show what your quality assurance processes are, and also to define what your quality control processes are and the data associated with that. So yes, it is a lot to do, but it's a very, very important aspect of everything that we do within metabolomics. So I sometimes talk about what is fit for purpose in targeted and untargeted assays, and it's very different for the targeted and non-targeted, as you'll see in a minute. So, fit for purpose in a targeted assay, well, we're told very kindly by the FDA what is fit for purpose within there. Okay, so if you go and have a look at the website there, the bioanalytical method guidelines for method validation within there. And so for a validated method, you should be demonstrating a various number of characteristics, including selectivity, accuracy, precision, and recovery within there, calibration curve, sensitivity, reproducibility, and stability within there. All the things that you should be doing, and by showing that, you're showing that that assay, targeted assay, is fit for purpose within there. But for an untargeted assay, it's very different. Obviously, for a targeted assay, we know what the metabolites are. We're actually focusing on developing a method to analyse those. For the untargeted, we don't necessarily know what the metabolites are. There's going to be hundreds or thousands that we're typically detecting within there. We're trying to get this snapshot of metabolism. And again, of course, there's no single analytical method which will analyse every single metabolite in a sample, based around sensitivity, dynamic range, dynamics of metabolism, analytical method itself. So here, how do we define what is fit for purpose? Well, we can define whatever we want, as long as we're defining it's fit for purpose and showing that it's fit for purpose based on those definitions, then that's absolutely fine within there. So for me, fit for purpose for a non-targeted method is making sure that it's meeting certain criteria. In my view, those criteria ensuring that it's reproducible, repeatable. Okay, so making sure that we're getting the same quality data every single batch, every single study that we do within there. And of course, you can still validate your assays to be able to do that, even for a non-targeted, untargeted study within there. So one aspect, very important aspect, is providing evidence for data quality, and again that differs or can differ slightly between targeted and untargeted studies within there. So targeted studies, again, very, very important, FDA defining guidelines of what we should be doing within there, and again have a look at the bioanalytical guidelines, bioanalytical method guidelines for that. But basically you're preparing a QC for each analytical batch, and you're ensuring that the acceptance criteria that are defined either by the FDA or your own acceptance criteria are being met for that. And because you're applying in the targeted assay calibration standards across, that QC sample is applied just for that batch, analytical batch, and you apply a different QC sample for different analytical batches as you go on. Might be the same composition, but you'll be preparing them differently. And of course, if they don't meet the acceptance criteria, okay, then you should go away and reanalyse your data. It's not high quality data. For untargeted metabolomics, obviously we're applying typically a single or small number of QC samples within there. So for the targeted studies, we're typically applying 3 QC samples, a low, a medium and a high concentration QC within there. There's no acceptance criteria that have been defined by the FDA. Okay? Part of the survey that we'll be doing is looking at what people are applying at the moment within there. So for example, some groups will apply a relative standard deviation across all QCs of 20%, some will be applying for 30%. It doesn't matter what you apply as long as you're reporting that, and as long as you're defining it clearly within everything that you're publishing, for example. The important thing about QC samples in an untargeted metabolomic study, if you're doing multiple batches, you want to make sure it's the same QC sample across all those analytical batches. So again, you can use that for quality control and ensuring that you've got good quality data within each batch, but can use it to be able to measure the quality across the different batches, and also be able to normalise and integrate different analytical batches as well within there. And again, if you don't meet the criteria you set, it's no setting, okay, it doesn't meet it 20%, we'll move it up to 30%, it's not set, it's not met acceptance criteria, so you should be reanalysing the data. And this is just one quick example of what we do. We've got quite a lot of people doing now. So this is a study that I'll talk about on Wednesday or Thursday, I think. This is a SIFTY study. So this is David Broadhurst. I don't know if he's here. No, he's not waving his hand. He performed some quality assurance on that. He's got some very good software for being able to do that. And basically, the QC samples is just 3 analytical batches with about 100 samples each. QC samples, you can see all clustering tightly together. They're the blue circles within there. And then the biological variability across there is obviously much larger than that. And this is what we want to be seeing. Same sample analysed multiple times should be reproducible within there. I also I would recommend in publications, for example, to define how many metabolite features, okay, so MSED potential time pairs, actually meet your acceptance criteria. Okay. So if you're measuring 10,000 features and only 1,000 of those are actually meeting the criteria, then your method's probably not appropriate for what you're trying to do. And finally, just a quick example of good record keeping. So this is something else that's happened in a project that we're involved with, or I was involved with, the Who's-Met study. So these are different, as you're going along, if you look on the top graph along there, these are different analytical batches across 1,200 samples that we analysed within the Who's-Met study. So there's 20 analytical batches there. And you can see that sudden drop in sensitivity there. And actually, we didn't know what that was straight away, but we had good record keeping. And then we found out that's after the annual preventative maintenance. Okay? So they clean the system so well, you get a drop in sensitivity. I know it doesn't make sense, but we see this regularly. But by doing that, by keeping the records, we could define what had happened, and actually we can make sure that what we're doing afterwards, we're re-equilibrating the system before we do any studies after any preventative maintenance within there. So really, really important. That's just one example of multiple that I could give on record keeping. So the key points. So quality assurance is an important process. We're not all applying it at the moment. We should all be applying it at the moment, both for targeted and untargeted assays. So QA are the planned set of activities to ensure quality, what you're doing before you actually perform the study. And basically in QA and targeted assays, the criteria are already out there. Go and have a look at those recommendations, those requirements by the FDA. In untargeted assays, they're not defined yet. Necessarily we shouldn't be defining them in great detail, but we should be able to report those in anything we do. And really do emphasise using QCs, using QA, integrating those is really, really important.